All right, hello, here we go. We are going to do some review of tangent and sine, and I'm going to take the problems right out of your workbook, your problem book, and your problem book can be found online. You can go to the resources section of RenWeb to get that link. So you can pause this right now and go get that, or you can just listen to me read the problem. So I'm on page 40 in the problem book, and I'm looking at number 4. And number 4 says that we're standing 50 meters from the base of a fir tree. So here's our fir tree. And remember, whenever we're doing story problems like this, we're making a lot of assumptions. We're assuming that this tree is straight up. We're assuming that the ground is level, and then we're making a right angle with the ground. And this is that we're 50 meters away. We're going to assume that that is a correct value. And we're standing over here. And the problem says that we're measuring an angle of elevation. Now, here's another assumption. The angle of elevation is assuming that we're as close to the ground as possible. So you're putting your eyeball on the ground, or pretend that you're an ant. You're down to the ground as low as possible. I don't know, maybe there's something smaller than an ant you could be. Get your eyes down to the ground as much as possible, and you're measuring from the horizontal up. That's angle of elevation. So that means if we're right here, we're going up, angle of elevation to the top of that tree is this angle right here. And it's 33 degrees. We measured it with a protractor, happen to have one in our pocket. And we want to know, how tall is the tree? That's our X. How tall is the tree? Now, we know from our trigonometric ratios that tangent, the very first one we learned about, tangent of an angle, and we call that angle theta, just an O with a line through it, it's a Greek letter. Tangent of theta equals, and it's a ratio. It's a ratio of some sides of a right triangle. What is tangent of theta? Which two sides? It's opposite over adjacent. Now, we also have a hypotenuse. Here's our hypotenuse. For tangent, we don't use the hypotenuse. We're using opposite over adjacent, and that's going to work perfectly for us here because from our 33-degree angle, opposite our 33-degree angle is the height of our fir tree, and adjacent to our 33-degree angle is the 50 meters away that we know that we are. We're not talking about the hypotenuse in this case. So we can write the sentence. Think of it as a sentence. It's an equation that the tangent of our angle, which we know is 33 degrees, equals opposite. Opposite is X over our 50 meters. Okay? And then we're going to just solve this. We're going to solve this for X. So I need to get rid of that 50. I'm going to multiply both sides by 50 because 50 is on the bottom. Whatever's on the bottom is what you multiply by. So these 50s cancel out, 50 on top, 50 on the bottom. And now I have X all by itself on the right side, X. And then on the left side, I have 50 times the tangent of 33 degrees. Now, this is essentially the exact answer, 50 times the tangent of 33, but I want a number. I want to know how tall is this tree. Now, the problem does not ask us to tell the height of the tree to the nearest meter, tenth of a meter, hundredth of a meter. So I'm going to work this out on my calculator, and I'm using an iPhone. I turned it sideways, the calculator app, and that means on an iPhone or on any phone app, you generally have to put in the degrees first. So 33, then hit the tan button, and I got 0.649407593. It's a big long number. I highly suggest you use that number now. Don't write it down as 0.65. Use the number in your calculator, multiply that times the 50, and we get that X equals 3247037. There's a bunch of numbers. Now, it didn't tell us where to round. So we could say x equals just the 32. If we want to use tenths, we can say x is approximately equal to 32.5. That's the tenths. The tenths place, one decimal place, the tenths. And that's generally a good place to go if they don't tell you where to round, okay? And let's not forget our units. This tree is in 32.5. It's not 32.5. It's 32.5 meters. X is 32.5 meters. That is number 40.4. So let's take a look then. Let me clear the screen. And we're going to take a look at number 7 on that same page, 40.7. And if you remember, this was Pocahontas. Pocahontas is standing on a cliff way above the sea. Here's my sea. Here's my cliff. It happens to be a direct straight drop off because we're making that assumption that this is a right angle and our cliff is straight up, and here's Pocahontas up here looking out over the sea. She sees an approaching ship and she measures its angle of depression. Now, an angle of depression is very much like the angle of elevation. The angle of depression is if her eye was right on the ground here and she was looking out straight, that's 0 degrees, okay? Out straight is 0 degrees. An angle of depression then, an angle of depression down to where we see a ship, and boy, can I not draw a ship? I'm drawing a sailboat. All right, this right here is our angle of depression because it goes down from her 0 degrees. This right here is our angle of depression. And her angle of depression is only 9 degrees. 9 degrees. Very small. So she sees this approaching ship and she measures its angle of depression of 9 degrees, and we want to know how far from the shore is the ship, and that's down here. That's this down here. How far away from the shore is the ship? Well, if that's what we want to know, then that's our x. That's what we don't know, right? So we've got the ship over here. We're assuming it's a dot. We've got Pocahontas up here. We assume that she's an ant. And we've got a 9-degree angle of depression. Now we can go a couple of ways with this. And what we want to know, what did it ask us? How far from the shore? Oh, she's up 380 meters. So we know that this is 380 meters, this cliff is 380 meters up. She's way up there, 380 meters above the sea there. And so we can go a couple of ways with this. Now, we know that this too, we're making the assumption that this is a right angle. So if this is a right angle and this little part here is 9 degrees, then that means that the remainder of this angle, this one, is 81, right? 90 minus 9 is 81. The other way we can look at this is that this is a straight line right here, her line of sight. This is a straight line here, the line of the sea. Those are parallel. And if we consider her line of sight here to be a transversal, then this angle and that angle are alternate interior angles. And alternate interior angles we know are equal. So this is a 9-degree angle down here as well. Now, if we think about it, this whole triangle, the angles have to add up to 180 degrees. And we've got a right angle here, that's 90. So if we know this is 81, then we know the one down here has to be 9 because they have to add up to 90. So now we've got angles everywhere. We've got an unknown, and we've got 380 meters up the cliff. So we need to write the sentence. What's the sentence? Well, here's a hypotenuse. And we don't use hypotenuses when we're talking about tangent. So let's talk about tangent. Tangent of theta equals what ratio? What two sides? Opposite over adjacent. As soon as you start a test or a quiz, you should be writing that at the top of your paper. Opposite over adjacent. So do we use the 9-degree angle or do we use the 81-degree angle? Well, we can use either one. Let's use the 9-degree angle. Let's use this angle down here. If we say the tangent of 9 degrees, what's opposite the 9 degrees? Which side? Is it x? We need to know x. That's not opposite. What's opposite the 9 degrees is our 380. And the adjacent, the side closest and touching this angle, the side touching the angle we're talking about, is x. Well, how do we solve for x now? We always multiply by what's on the bottom. Multiply both sides by what's on the bottom. So I'm going to multiply both sides of this equation by x. So I have x now on the left, and the x's on the right cancel out. X on bottom, x on top, that means they cancel out. So I have 380 on the right, and I have x tan 9 degrees on the left. Well, how do I get x by itself? I've got x times something. X times something, I just divide by that something. Divide by tangent of 9, both sides, tangent of 9. So now those cancel out on the left. I've got x by itself, and my answer then is 380 divided by the tangent of 9. And I can put that into my calculator or my iPhone. Again, if you're using a phone, you want to make sure that you put the angle in before you press tangent. If you're using a calculator, you do tangent and then the angle degrees. So I'm going to take 380 divided by, now on a phone or on your calculator, it's a good idea to use the parentheses. And on your phone, they're likely in the upper left corner. So 380 divided by parentheses 9 tangent. Close out those parentheses and hit equals. And I get 2,399.2255755.7, and it actually goes on beyond that, and it is not a repeating. And so I'm going to round this one because it's such a big number. I'm going to round this one to the nearest meter, that's what I was looking for. So that's 2,399 meters. 2,399 meters. Now, if you wanted to use the 81-degree measure, we can write that as well. Tangent, our sentence of our angle, 81 degrees. Tangent of 81 equals, now what's opposite? Opposite the 81 is the x, so x goes on top. And then the adjacent to this angle, the adjacent to 81, is the 380. So x over 380. So we could say now that the tangent of 81 times this 380, if we multiply by 380 on both sides, times tangent of 81, that equals x. And if I do that, 380 times parentheses 81 tangent equals, I get 2,399.2255755765516. It's the same number. It is the same number. And of course it would be the same number, 2,399 meters. That's Pocahontas. So let's take a look now at a place where we have measures, but we don't have angles. And for that, we need to turn far ahead in our book to page 52. Page 52, number 6. And for this, I'm going to go to Desmos. So let me first open Desmos. And if you have not used Desmos, it's very easy to do. Just go to Desmos, DESMOS.com. And it actually does graphing for you. So let me do a share now with our graphing calculator. And you can put in, drag this around, you can put in an equation and it will graph it for you. So I'm looking at 52.6. It says the circle x squared plus y squared equals 25. And so when writing that, if you use the up caret, that's shift in the number 6. Shift in the number 6. X squared plus y, then shift in the number 6 squared equals 25. And we know, of course, that that is a circle. That's the standard equation of a circle with its center where? At the origin. And a radius of, this is r squared over here, so that's 5. Radius of 5. This says that this circle goes through 5, 0, and 3, 4. Well, we can see that 5, 0 is right here. And 3, 4 would be right here. So no problem, got those. And I think we can mark those here, 3, 4. And 5, 0. And we can click the label button, so they're labeled. And then it says, to the nearest 10th of the degree, find the size of the minor arc AB. So it says that 5, 0 is A. This is B. And we want to know essentially, what is this angle here from A to B back to the origin. And so we need to consider then, what do we have? If we're trying to find the angle from B down to the origin and over to here, over to here, how far over do we go to get to B? Well, we go over 3, right? We go over 3. And then we go up 4, right? Over 3 and up 4. So if we're looking at this as a triangle, then we've gone over 3 and up 4. And I want to know this little angle down here at 0, that's opposite over adjacent. So let me go back to our whiteboard. We've got a triangle. It starts at the origin. It goes over 3 and up 4. And we want to know, what's this angle right here? This is our theta. Well, we're not using our hypotenuse, so we got to be using tangent. Tangent, theta is opposite over adjacent. And so what's theta? We don't know what theta is. Tangent of theta, I don't know, but I do know opposite. Opposite is 4. Adjacent is 3. So what we have then, if we want to know what tangent is, what theta is, we need to take what we call the inverse tangent, right? Inverse tangent of 4 over 3. You do that on your calculator and on your phone very similarly. You hit the second button. When you hit the second button, your tangent suddenly changes into a tangent with a -1 behind it, like I have it written. On your calculator, hit 4 divided by 3 equals, make sure you hit the equals, and then inverse tangent. That's on your phone. On your calculator, you can do second tangent and then 4 divided by 3 equals. On your phone, make sure you do 4 divided by 3 equals, then inverse tangent. And for this one, I got theta equals 53.1301.023, blah, blah, blah. It keeps going. Now, this question says, find the angular size of this angle to the nearest 1/10 of a degree. 1/10 of a degree is 1 decimal place. So the correct answer to this is 53.1. 53.1 what? Degrees. Yes, 53.1 degrees to the nearest 1/10. That's 1 decimal place. 1 decimal place. All right, I'd like to do a couple of problems related to sine. And these are problems in your problem book, but those that we have not done before. We have not done these before. So let's take a look on page 49 at number 1. It says Taylor lets out 120 meters of kite string. Well, first of all, let me tell you, it's always going to be a right triangle. So you can set up a right triangle straight up. Just draw your right triangle. 120 meters of kite string, and then wonders how high the kite has risen. So Taylor's over here on the ground with his eye or her eye, right on the ground, or talking to the ant whose eye is. And we've got 120 meters of kite string going up to our kite. Hey, geometrically, there's our kite. There's our kite up in the air, and Taylor wants to know how high off the ground. So that's our X. How high off the ground is the kite if he or she lets out 120 meters of kite string? Now, do we have enough information here to figure that out? No, we need something else. Well, Taylor calculated the answer because he or she used a protractor to measure the angle of elevation. Remember the angle of elevation, ant-side view, it's 63 degrees. So how high is the kite? Well, can we use our tangent ratio here? Tangent is opposite over adjacent. Do I know opposite over adjacent here? There's opposite, but here's adjacent. And it did not say that Taylor knows how far away they are. It says we know this. This is our hypotenuse. And this is where the sine ratio comes in. Sine of theta equals opposite over hypotenuse. If you see a hypotenuse, think sine. So here we've got the sine of our angle, and that's in degrees. Sine theta, sine angle, degrees, degrees, degrees. Think of that. When you see degrees, that's what goes in the sine. All right, and it's opposite. Opposite we don't know, over hypotenuse, 120. Now, how do I solve for x? I need to multiply by what's on the bottom. Multiply both sides by 120. Those 120s cancel out, leaving me x by itself on the right, x by itself on the right, and then 120 times the sine of 63 degrees. And if I do that, again on your calculator, You need to do 120 times parentheses 63 sine, and make sure you don't have your second button on. Look at that button. Does it say sine or does it say inverse sine? Make sure you push the second button so that it says sine if you had it on before. And I get that x equals 106.9207, blah, blah, blah. Now, did it ask me to round this in some way? Yeah, it does. It says, how high is the kite to the nearest meter? To the nearest meter. That means nearest whole number. Nearest whole number. So this is 106.9. I got to look at that 9, and I'm going to round up. The nearest meter would actually be 107 meters. And there's another part to this. It says, what assumptions did you make? Well, we assumed that the kite string was taut and straight. We assumed that Taylor measured her degree correctly, right? We assumed that this was a right angle. So we make a lot of assumptions when we talk about real world problems. So always keep that in mind. If the problem says, what assumptions did you make? Or why could this possibly be incorrect? Well, it's because this is a real world situation. And we have to consider that everything isn't straight and perfect and make a right angle every time, okay? So that's sine, opposite over hypotenuse. So let's take a look at number 2. 2 says find the sine of a 45-degree angle, but use your calculator only to check your answer. What? A 45-degree angle? I want to know the sine. The sine is opposite over hypotenuse. How am I, what? Don't use my calculator. The sine of 45 degrees. Opposite over hypotenuse. What do we do? Do we know the measures of any of these sides? They didn't tell us. But wait, what kind of triangle is this? If this angle is 45 degrees and this angle is 90, then this angle is also 45 degrees. We've got a 45, 45, 90 triangle. That's one of our specials. We should know the side ratios of a 45, 45, 90. It's what? Well, these two, because they are opposite, our equal congruent angles are equal to each other. 1, 1, not 2, square root of 2. And you can use the Pythagorean theorem. 1 squared plus 1 squared equals the hypotenuse squared. 1 and 1 is 2. The hypotenuse is root 2. So we do know these measures then. We know that the opposite is 1. We know this one over here is 1. We know the hypotenuse is root 2. So sine of 45 equals opposite 1 over hypotenuse root 2. And I can leave it like that. The sine of 45 is 1 over root 2. Now, if I take 1 on my calculator and divide it by root 2, I get 0.707106, blah, 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 blah. That's what 1 divided by square root of 2 is. If I take the sine of 45, I get 0.70710678, blah, 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 blah. That's a 0 there. I get the same number. 707.106 It is the same number. So we've confirmed that the sine of 45 degrees is 1 over the square root of 2. Without even using our calculator, we can say it's 1 over the square root of 2. And anytime you have a special triangle, you definitely can use your calculator, but it's cooler to me to use your knowledge of special triangles and write it as a fraction. Write it as a fraction. Use those roots and write it as a fraction, and don't use your calculator. And specifically, if on the quiz or test I tell you not to use your calculator, or on a specific problem like I did on this one, you're going to want to use your knowledge of special triangles. So finally, let's see, what was our last one? On page 50. Page 50, we're looking at number 12. It says a right triangle. I'm telling you, we can't use sine or cosine or tangent or any of these ratios without using a right triangle. So we've got a right triangle. It says it's got 123 foot hypotenuse, 123 feet on the hypotenuse. Hypotenuse is always opposite the right angle. And a 38-foot leg. Which leg? Well, it didn't tell me which leg. So I'm just going to pick one. It's got a 38-foot leg. To the nearest 10th of the degree, what are the size of its angles? Well, I know that sine of an angle is the opposite over the hypotenuse. And I've got a hypotenuse here. This is our hypotenuse. It told us 123 feet. So if I want to find theta now, I need to know the opposite. Which angle is opposite to 38 feet? Which angle is opposite to 38 feet? It's this one right here. This is our theta. So in this case, we've got sine theta equals opposite 38 over hypotenuse 123. And that means theta is the inverse sine of 38 over 123. Remember, on your phone, it equals, after you do that division, 38 divided by 123 equals, then second, make sure that your sign has that little -1 up there, inverse sine. And I got theta equals 17.9955477, blah, blah, blah. Okay, now what did our question say? Our question was number 12. It says to the nearest 10th of a degree. To the nearest 10th of a degree, what are the sizes of its angles? It wants us to find actually both angles. But to the 10th of a degree, so I'm rounding to this place, this 1 decimal place, so I've got to look at the one behind it. Well, that 9 tells me I've got to round up, but if I round up from 9, I get a 0. So theta equals 18, but this says specifically 10th of a degree, so you need to put that 0.0 on there. That is the correct rounding there. Rounding to the 10th means it wants to see the 10th place, and the 10th place in this case would be a 0. And don't forget degrees. So if this is 18 degrees and this is 90 degrees, how much is that one? Well, 180 minus 90 minus 18 equals 72, if my brain's working today. 72 degrees up here. 72 and 18. And we do need the 0.0. It asks to the nearest 10th of a degree. There we go. So that's inverse sine. Inverse sine, just like inverse tangent, you just have a hypotenuse involved instead of both legs. So that's my review of sine, inverse sine, tangent, and inverse tangent. I hope this was helpful because next up we have a new trigonometric function called cosine, and there'll be a full video on that coming up next.